A buoy is a device which floats on the surface of the sea and moves up and down as waves pass. For a certain buoy, its height above its position in still water, y in metres, is modelled by a sine function of the form y equals a half sine 180t, where t is the time in seconds. Part A. Sketch a graph showing the height of the buoy above its still water level between 0 and 10 seconds, showing the coordinates of the points of intersection with the t-axis. Right, so we're talking about the sine graph, and we've got a couple of transformations to do. We've got a 180 inside the brackets there. We've got a 1/2 on the outside. So just to begin with, let me just draw the basic sine graph for now, and then we can think about how that's going to get transformed in a moment. So basic sine graph looks like this. Right, so that's my graph of sine. Now, first of all, the 1/2 on the outside there, that's on the outside, so it affects the y coordinates. So it's going to be multiplying the y coordinates by 1/2. So instead of going up to 1, they're going to go up to 1/2. So a half sine x looks like this. Or if we're talking about having a t-axis instead of an x-axis, it'd be half sine t. Right, the 180 on the inside there. Now, because it's on the inside, it affects the x coordinates, or in this case, the t coordinates, and I need to do the opposite. So instead of multiplying by 180, I would divide by 180. So that would mean that this coordinate here would become a half. This coordinate here would become 1. This coordinate here would become 1.5, 2, and so on. So let me just repeat that. Actually, I'm going to write it underneath just to make it really clear. Dividing all my t coordinates by 180. So 90 divided by 180 would become 1/2. 180 divided by 180 would become 1. 270 divided by 180 would become 1.5, or 3/2. 360 divided by 180 would be 2, and so on. I now need to draw my graph all the way up to 10 seconds. So let me just try and move this to one side, and so I can draw my actual answer to this question over here. So I'm going to put 1 and minus 1 there. We know our graph's only going to go up to a half and minus a half, but I'll just put those there for now. And then we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going between 0 and 10. And like we said before, we're only going up to 1/2 and minus 1/2 on the y-axis. Our maximum point here is at 1/2. So we go up to 1/2 here, then back down to 0 at 1, down to minus 1/2 at 1.5, and then back up to 0 at 2, and so on. So this is what my graph should look like, more or less. This is the graph of y equals 1/2 sine 180t. So that's part A. Part B. Write down the number of times the buoy is 0.4 meters above its still water in the first t seconds. Sorry, in the first 10 seconds. So 0.4 would be roughly about here. So it's going to be 0.4 meters above its still water position. Here, 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 and so on. These are all the times when it's going to be 0.4 meters above the 0 position. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. And part C, give one reason why this model might not be realistic. Well, lots of different things you could say here. One thing I would probably say is it's unrealistic that the amplitude of these oscillations is always going to be 0.5 meter. If you have a particularly strong wave, for example, it would make the buoy go higher than 0.5 meter. Or if you had a particularly weak wave, it might not even move at all. It's also unlikely that the time period to do one cycle would always be 2 seconds. This model is saying that the time period is always going to be 2 seconds. That's for it to start from its original position and get back to its original position. It takes 2 seconds. So again, it's unlikely that it would always take 2 seconds. So I would either say, in terms of actually answering this question, I would say unlikely, buoy would reach a constant maximum height of one of 0.5 meter. Would reach a constant maximum height of 0.5 meter. It is likely to change with time as the waves change strength, or as the weather changes, or something like that.